Okay.
So in the last session, we just solved the latest PTQ, right?
What do you want to do in this session? Should we move forward to week 5? Should we again practice and clarify the concepts? What do you say? QIQ, lecture 5. Lecture 5 of which week? So again, most of you are demanding for PYQ. Nikhil is saying week 5. Okay. TRC and GRC. What is GRC? Is there anything called GRC in our course? DRC, right? So let's do one thing. Uh, let's analyze the papers and extract the concepts. Okay, we will go through the paper and we will not solve it, but we will extract the patterns from it. And after that, we will keep writing those patterns in our whiteboard. We will come back, we will cover those concepts, and we will try to clarify all related doubts. After that, we will, according to the spare time, we will go back to those papers and then we will solve those papers, right? It will give us relevant knowledge, very selective preparation of what is relevant to the exam, because the exam is very close. So we cannot afford to like kind of have everything. So we need to do this depth first search. It's a squeeze practice dot space, right? Okay, so let's go to this paper. It is, I think, September 2025 paper. Yeah, September 2025 term. So in this question, they gave the data. We can see the schema and like two tables are given, and they had given the relational algebra query with a division operator, right? So what is the pattern here? What they are asking? They are trying to test our relational algebra and our division operator uh, knowledge, right? So I'm just writing the concepts in the whiteboard and I will just do +1 as I will see the related questions. For example, currently I went to the whiteboard. I wrote two things, relational algebra, division operator, and I added +1 in the front of them. So we will keep doing that to know which concepts are being asked again and again. So in this question, there is a table given. SQL query is given in the options, and they are asking Choose the SQL query that returns the names and scores of students from Australia or Germany who scored more than the average of all students, right? So this is about SQL subquery concept, right? Finding these type of things is possible when you know how to use subqueries, because if you focus on the question, they are asking who scored more than the average of all students. So we are making the collection multiple times. That means we will have to use subqueries. So if you have good knowledge of subquery, you can solve this question. As simple as that. Now again, they had given two different tables, and an SQL query is given. Again, it is a subquery type of uh, SQL query, and they are asking for the output this time. So again, I will add +1 for that SQL subqueries. A relational database contains two separate tables called drivers and teams. The drivers table has these attributes, and teams table contains these attributes. The following insert statements were executed to populate the tables, and some insertion queries are given, and one SQL query is given, which is to ask the dimension of the output, how many rows, how many columns, and so on. So what do you think? What is required to solve these type of questions? What type of insight do we need? First of all, DDL, right? Our not DDL, it is insertion. So DML, understanding the schema properly, you should see the schema and you should understand that how to form a relationship between multiple tables. For example, here you can see that team ID is being used in drivers table, right? So there is a relationship between them. These type of things you should observe in the first go itself. And then you should understand, if we are inserting something, then is it allowed to be inserted or not? For example, when we were solving a similar type of question in the last session, what happened at that time? Um Only there was were check p condition, right, which was disallowing some insert queries to run. There was one check p condition. So these type of things we should be aware of, understanding the schema, and then the DML part, right? The student table is given, and which of the following SQL command is used to provide update authorization of the table student to instructor? I don't think it is quite common in the quiz one, asking these type of questions, rules, and all of that. That's why we cannot be 100% sure that whatever pattern we are collecting will come as it is in the exams. Maybe there can be some new type of questions that are never asked before, right? Currently, what we are doing, we are selectively preparing to follow that 80-20 rule, but it is not guaranteed that we are covering 100% just by collecting these patterns, right? For example, this question, if you go and observe other previous term questions, you will not find this type of question, but it is asked in September 2025. So things are in like things are variable, right? But still, if you have authorization, SQL authorization knowledge, then you can easily find out the correct answer. This question is all about creating views. No, they had given a schema. Choose the correct SQL command to create a view by selecting two column names and department name from instructor relation. Select those instructors having names ending with S and from the biology. department, right? So I would say simple SQL knowledge is enough here. And one more thing, the syntax to create views, right? It is also required here. The schema is given and they are giving you SQL queries, relational algebra, tuple relational calculus, domain relational calculus. So this type of question is very, very, very common in quiz one. Like you can even uh, assume that one question of this type will be present in your exam, right? Because we can see this pattern repeating again and again. So what happens in these type of questions, the schema will be provided and they will give you some statement just like they give you in SQL questions where they give you a statement and then you write SQL queries. In the same way, they will give you a statement. Then you have to select the correct SQL queries or uh, like TRC relational algebra, whatever is given, you have to select the correct ones out of them. So for that, you need the, of course, you need the knowledge of relational algebra, basic SQL, right? 1 minute. I'm collecting these patterns. I will show you what we are doing. And TRC, DRC. I'm using them in a single line. This type of question is also common. You can observe the previous term questions. A single question is always uh, evident from those papers. So a schema is given and you can observe the partial participation, full participation, one-to-many cardinalities. So like your knowledge on ER diagram should be very clear, right? You should just see the ER diagram and you should understand which symbol is denoting what. These double lines are denoting what? Full participation, right? And this arrow is showing that the cardinality from the company side is 1 and no arrow means the many. This means company and items have this produces relationship which is one to many relationship with full participation in both the sides, right? You should understand what this double oval is denoting. Can someone tell me what this is denoting? Multi-valued
Multivalent.
attribute, right?
Yeah.
Yes. Which of the following statement is or are correct? There might exist an item that has not been produced by any company. So you can see in this question, they are testing your knowledge on interpreting the type of cardinality and the type of participation. So when they are asking there might exist an item that has not been produced by any company. So what they are testing, do you understand the full participation part of these items in this producers relationship? Because there is a full participation, then this statement is incorrect, right? They are asking there might exist an item that has not been produced by any company. So they are indirectly asking you that can there be any item which is not participating in this relationship? Am I right? They are indirectly asking you, can there be any item that can remain independent from this relationship? But no, this double line is directly saying that there must be at least once, every single item should participate in this relationship at least once, right? So this is about interpreting the cardinality and the participation from ER diagram. If you observe the some other papers, there is one more thing, one very common question that is asked in many terms, and that is about uh, finding out the minimum number of tables required to denote this whole ER diagram. minimum number of tables. So if you want to collect this information, whatever is shown in this ER diagram, in the form of tables, right? Because a diagram is just a diagram, it is just a representation of your database. But when you want to make a concrete database, actual instances, then the minimum number of tables required, so that count, you should understand, or you should have this knowledge how to calculate that minimum count. Can you tell me what is the minimum number of tables required in this ER diagram to like denote all this data in the form of tables? Between company and items, you can see there is a one-to-many relationship, right? Between customer and items, there is many-to-many relationship. And phone number is multi-valued attribute. Is it enough hint to understand the minimum number of tables required for this ER diagram? One, we solved very similar question in the previous session, right? Is there no one who can answer this question?
5.
5, sir.
5.
5, sir.
Can you explain how? Like, I want some reasoning behind it.
3 for the entity sets, 1 for the many to many orders, and 1 for the phone multi variable attribute.
So, company, items, customer, orders, and phone number.
Yes,
Why not produces?
it's 1 to many, so you can accommodate it in one of the tables.
If it is one to many, then we can collect the relationship information by storing the foreign key in one of the table, either company or items. Are you saying that?
Yes,
In which table, according to you, we should store that foreign key? Company or items?
items.
Sure. Yeah, you are right. The minimum number of tables required to collect this type of data in a database, the minimum number of tables is 5. But is it a good idea to store the foreign key and store the data like this, or should we maintain a separate produces relationship? It is a matter of fact, right? We cannot like be concrete about it, but you will know these concepts in week 5 and week 6. That is why I emphasized this. You will, maybe some of
It's
you
not a
already
hard
started.
rule, but
Yes.
depending on the size, I think we can
Hmm,
adjust.
hmm.
But minimum, it should have 5. It cannot have less than 5. That becomes a problem.
Yes, the minimum threshold is making us sure to answer 5. Otherwise, we cannot be completely sure about it, right? It's just the choice. Okay, so
Sir, can you explain one more time actually why produces are not in scope?
yeah, so the reason behind it is one to many relationship, right? So just try to formulate the meaning of this. What is the meaning of one to many relationship? A company can, a single company can be associated with multiple items, right?
Yeah.
One minute. Yeah. So a single company can be associated with multiple items. So let's assume the concrete data. We have three companies, company A, company B, and company C. This is their company ID, let's say A, B, and C. And there are three items, or let's say five items, uh, 1, 2, 3, 4, and 5. So company A created or produced 1 and 2. Company B produced 3 and 4. And company 5
Sir, are you
produced.
writing on some screen? Because we can only see the quiz
No, no, I'm
practice.
just talking.
Okay.
So company C produced item 5. Okay. We have three companies, ABC, and we have five items, 1, 2, 3, 4, and 5. Company
Yes.
A produced 1 and 2. Company B produced uh, 3 and 4. Company C produced item 5. Okay.
Okay, sir.
Just have that simulation in mind.
Okay.
Now, we want to collect this information in the form of tables. And our main concern is that this relationship should be stored, right? This
Yeah.
relationship also be should be stored. Now, I have multiple ways to do it. Let's just go to the whiteboard. I think it will be better that way. Otherwise, it will be just too much simulation. So this is company, and we have company ID and the company name. Again, we have item ID and item name. One, two, or ABC. Name can be anything. One, two, three, four, and 5. Name can be anything. There is a relationship between them called produces. Now, if we have one to many relationship, that means a single company is associated with multiple items. So I can leverage this one to many relationship to store a variable here, which we call foreign keys. It can be CID, company ID. And this company ID can be stored here. Like I can have item 1 associated with company ID A, and this also with company ID A.
Yeah.
Third one can be associated with company ID B, and fourth one also, and fifth one also here. You know why I'm able to do that confidently? Because it is one to many relationship. I am 100% sure that from the company side, there is only one cardinality. There cannot be multiple companies associated to the same item. That's why I'm able to store this company ID here, right?
Right. Yeah.
So if we would have a many to many relationship, then it would not be a good idea to do that, because we would have to do something like this, A comma B, right? Because multiple companies can be associated with the same item,
Correct.
right?
Yeah.
And this is a very bad idea. That's
Okay.
why we even use a separate table for multi-valued attribute. So we don't want
Okay.
to create multi-valued attributes at all. That's why we said that we don't need a separate table for producers table, because we have one to many relationship or many to
Okay.
one relationship. In these two cases, we
Okay.
can ignore this producers table at all.
Okay. Thank you, sir. So, one related question: if I need to revise this ER chapter, ER diagrams chapter,
Yes.
which session will be the good one to quickly revise, sir?
I think tutorial, there's one tutorial, I think it is tutorial 4.3 in your uh, course page. I think it is covering everything on AR diagram.
Tutorial 3 on week 4, sir?
Yes.
Okay, okay. Thank you very much. I'll
Is it
check.
same for one to one also? We don't require additional table.
What do you think?
Yeah,
Don't require.
we don't require.
What do everyone think here? Will we require it? A separate relationship table in one-to-one relationship?
No.
No, right?
Okay. So also for weak entity, we need an additional table.
Right.
Correct. Okay. Okay.
Even in one-to-one relationship, things are more convenient. Here we are creating CID here on the many side. We are creating foreign key on the many side. But if it is one-to-one relationship, you can create the foreign key either on the right hand side or the left hand side. Both are just one, right? Having one cardinality. So you are just directly connecting the rows, one row with one another row. Okay, so what did we learn? What is the pattern? We should understand the ER diagram so well, and we should have the knowledge of cardinalities properly, right? Because this minimum table question is also being formed from the knowledge of cardinalities. Okay, so this is not very usual, but this is from week one, right? And I think we repeated it again and again and again, these type of concepts. The abstraction levels and the data independence. So I will add one point for that. I'm just adding the point as week one because it's not very large. So consider the table instructor. So again, data is given, a query is given. They are asking for the answer, and it is not your typical type of query. It is advanced SQL query. I will consider it advanced SQL. Consider the relation loan records. Select count star. Again, a query is given to you, and they are again asking for the output. So you can see how important SQL is for week one, right? Every second question is about SQL. A schema is given, ER diagram is given to be precise. Player table has 50 rows and teams table has 10 rows. Then what is the maximum number of rows returned by the following query? All the attributes are having not null constraint, and this signature indicates left outer join. By the way, these type of questions are also uh, kind of common, right? Especially the outer join. In Discourse, also someone tagged me, and I answered a very similar question. Finding out the minimum number of rows and maximum number of rows in outer join kind of scenarios. Sometimes it also asks natural join. For that, you need good knowledge of joins. Don't worry, currently we are just collecting the patterns. We will cover all of them. Don't worry. Suppose the on delete cascade constraint is not applied between the tables and we want to delete the record of team ID is from teams, then choose the correct sequence of SQL query. First of all, okay, team ID. So they are asking the sequence. For that, you need to understand how cascading works. I am adding that in the topic of referential constraints. Referential constraints are asked multiple times in this one. Which of the following SQL queries is or are used to create table teams? Again, it is checking your SQL knowledge, right? I will just call it basic SQL, basic DDL query. And this paper is over. let's also cover one more paper.
Sir, I have one doubt.
Yes.
In the SQL query, under where condition, if we have not given the joining condition,
Mhm.
will it take it as a cross Cartesian product?
If you had not
Similar
used
one
the join
kind
keyword,
was there in quiz.
you
More,
mean that you had not given any joining condition at all, right?
yes.
Then if
Where
it is not
where
in natural
condition
join,
is there, but
then it
joining
will be
condition.
Cartesian.
Okay, okay. So we should take it as Cartesian.
Yes.
Okay, okay, okay. Thank you.
Again, the schema is given, the query is given, they are asking you for the output. Again, covering it under basic SQL. Insertion, updation, deletion. So basic DML, right? ERC, DRC, they are asking you to match the TRC expression to its correct equivalent DRC expression. So this is just type of matching. And for that, you need good knowledge of TRC and DRC both. So I'm adding +1 for that. Schema is given, a query is given, and they are asking you what this query returns. So they are checking your knowledge on subqueries. A schema is given, query is given, again the subquery type of query. Again, they are asking what this query returns. Schema is given, and they had given you different relational algebra, uh, and you have to select the correct one.
Sir, can
Yes.
you just give some explanation of question number 6, double not condition? Just
Yes. So student, course, and enrollment. SID is here. Okay. So we have two entity set and one relationship set. Now consider the following SQL query. Select s.name from student S, where not exists. Select star from course C, where not exists. Select star from enrollment E, where E.SID is equal to S.SID and E.CID is equal to C.CID. CID denotes course, SID denotes student, right? So it is selecting the name of students where those type of course doesn't exist, where there is no enrollment between the student and the course. That means where student is not enrolled in any course, right? The name of those students who are not enrolled in any course, because this not exist here. Got it?
the second inner query will return not enrolled in any course.
No.
Yeah. Not exist returns true when the inner collection is empty, right?
Yes.
And inner collection will only be empty when these two conditions will be false.
Yes.
And what is the meaning of these two conditions being false?
No student in any course means no
Right.
enrollment of a student in any course.
Yep. So which option is correct?
Third
This
one.
one?
But sir,
Names of students who
Third
are
one.
enrolled in all available courses.
Sorry?
then
Oh,
we have
okay,
to
okay, okay. It is not exists here. So
yes.
the negation is being applied to this collection of courses, which is checking for the enrollment. So we are selecting such students where there is no existence of such courses where there is no enrollment with the current student. So what is left if we negate those courses where the student is not getting enrolled, like there is no existent in the enrollment table. So what is left?
Here not exist is used 2 times. So it should be enrolled
Doesn't
in.
matter about the being used 2 times. It is being nested. That is more important. So we are saying select the name from the table students where not exists. This will return true when the inner collection will be empty, and the inner collection is the courses collection where there is no existence of the enrollment between the student and the course, because it is checking e.sid with s.sid and e.cid with c.cid. So this collection will be empty when there will be no enrollment, right? And if it is not empty, then what does that mean? Hmm?
The if first not exist will give the where students is not enrolled, but the outer the second not exist, it will give the output where there should not exist even in even one such course. That's why the overall the output will be students enroll in all courses.
So to understand what is happening here, assume you have a table, you have three tables, A, B, and C. And C is containing some common attributes between A and B. You are saying that I want to select something from table A where there is not an existence of a collection, and this collection is from table B. These two are different entities, table B, where again there is not any existence of again a whole collection from a relationship set C, which is matching the attributes, the common attributes from A and B, which means it is matching the relationship. So what it is trying to do, when we are saying that in innermost query that I want to select everything that is matching here. So what we are trying to say, if we take the example of students and courses, we are saying that find out all such um, rows from C where there is a matching between A and B. There is a relationship between A and B, A and B. But C itself is a relationship set, right? So this select star will return all the rows of the relationship, right? Where there is a matching. And this not exist on that will return true if for the current A, let's say the current student is Bob and current B, DBMS, for these two current students, if there is at least one relationship in table C, then this exists will return true, and this not exists will return false, right? So what type of rows it is collecting? If we have Bob here, if we have DBMS here, and if both of them are not related, Bob had not enrolled in DBMS course, then this collection will be empty and this not exist will return true. And we are collecting such courses for which there is no enrollment, right? We are collecting only those courses for which there is no enrollment. And if we are moving this loop to every single course and checking, for example, if we have Bob here and we have DBMS, we have PDSA, and we have, let's say, MLF. This is the courses table. And in this, we have three courses. We are selecting each course from courses table and checking if this course, current student Bob, is enrolled in this course or not. Then it is checking, is it enrolled in this course? Is he enrolled in this course? Right. And imagine a situation where Bob is not enrolled in any of these courses. Right? So this not exists. What was returning true when there was not any existence, when there was no association between the current course and the current, between the current student and between the current course. If there is no association between them, then this condition will be true and that course will be selected. So if Bob don't have any association with DBMS, then DBMS will be selected in the output. Same for PDSA, same for MLF. Right? If there is no association, then only they will be selected. But if they are selected, what this not exist will return? Will it return true? Or will it return false?
False.
False, right? Let's say the PDSA is not selected MLF is also not selected. Let's say Bob had taken BDSA, Bob had taken MLF. That means this not exists condition is not going to select them. Only DBMS is selected. Will this outer not exist return true only for DBMS? No. It will only return true when no such course is selected, right? Am I right? When no such course, what do I mean by such? No such course which Bob had not taken. If Bob would have taken this, then this not exist will filter this out. So when DBMS is not getting selected, PDSA is not getting selected in this query, and MLF is not getting selected, we mean that Bob had taken all of them. That is why they are not being selected, because of this not exist. And when none of them is getting selected, then only this not exist is getting true. So what does that mean? This outer query is selecting only those students who are enrolled in every single course, right? So I don't think if like I do think that I have taken a lot of time just for a single question, but it is important because there is a chain of exists and not exists, and these type of questions are kind of confusing. When I was doing DBMS, then also it was very confusing for me. So I tried to simplify it with just using simple general names. I don't know if it was helpful for you, but if you see the query now, then you will clearly understand what is happening. There is an enrollment selection, and this selection not exist will be true when there is no enrollment. And this select star course is selecting all such courses which current student had not taken. And if this collection is being generated, then it means this not exist will return false. So when this not exist will return true when this collection is empty. So our ideal goal is to make this collection empty. And when this collection will be empty, when this condition becomes false, right? And this condition will only become false when the student is will be always enrolled with every single course that we are trying to select, right? So it was looking very simple, and but it's kind of confusing. Then see, we were easily being swayed by this last option, and if we would be going too quickly, then we would have selected this. That's why it's important to take your time and try to understand the queries and the different types of queries like relational algebra and TRC, DRC. We need to understand them really well and try to understand what is really happening in this query before reaching the conclusion. So this is again related to relational algebra. So I will add +1 for that. Simple SQL. In this, the product table is given. They are asking just for the average. I don't think it is complex at all. Basic SQL. ER diagram. Again, you need to just interpret ER diagram really well if you want to solve such questions. There is an aggregation here, right? Two entity sets, one relationship set, all of it being aggregated. Can you tell me what are the attributes that will be present in the aggregation? In this aggregation, which attributes will be present in this aggregation? All five? A1, A2, B1, B2, and C1, right?
Yes, sir.
And they are asking which attributes will be present in relationship set A1, this relationship. What is the primary key of this aggregation?
A1, B1.
A1, B1. And the primary key of E3 is E1, and A1 have its own attribute called D1. So which option is correct?
Last one.
The last one?
B1.
A1, B1, E1, and D1. Brilliant. I think you have good understanding of ER diagram if you are able to interpret this. So again, this question is again about relational algebra. So you can see the pattern. Relational algebra is being asked even more than TRC and DRC. Main role of query parser in query processing. The theoretical type of question, I will just put them in week one. Again, ER diagram is given, and they are again testing your knowledge on cardinality and participation. This will again come under ER diagram. Relational schema given, one query is given, which is about right outer join, and they are asking the minimum and the maximum thing that we already saw, right? About understanding the joins properly. Department, employee, and project given below. Delete from department query is given. How many total rows will be deleted across? So again, it is about a referential constraint. So I think this is enough for collecting the patterns. Let's see what we collected. So you can see most asked topic is basic SQL. I added the plus here. It should be here. Basic SQL and advanced SQL, and not even the type of that uh, roles, privileges, and these type of things. I'm just talking about subqueries. So the major portion of quiz one is just SQL. This is also SQL, right? Some questions rarely coming like authentication topics, authorization topics, and views. So please at least know the syntax of how to create a view, how to create a role, how to create a domain. At least revise the syntax of them. ERC DRC is being asked. I think it was 3 times we saw it, not 2. ER diagram is being asked multiple times. Week 1 topic was mainly, yeah, one question is coming, at least one question is coming in exam from week 1. And this joins was basically those outer join concepts, outer join questions, where they are asking minimum number of rows and maximum number of rows. Either they are asking the difference or they are asking either of them, minimum or maximum. And then referential constraints. In this, basically, they are asking the cascading concepts. What will happen if we cascade, right? In basic SQL, basically, the sometimes they give you the problem statement and among 4 options, they will ask you to take the correct option, SQL query option, or they will give you the SQL query and they will ask you the output, final output, right? In subquery type of questions also it is quite same. Division operator also is common in quiz 1, and relational algebra is being asked again and again. So now you tell me, out of these topics that I collected, what you are thinking you need to revise. We will revise that and then we will again go back to those sets and we will cover them quickly. Are you feeling ready for all of these concepts? Do you understand relational algebra well? Just give me a thumbs up. I will just iterate one by one. I will just see whom of you is quite confident with that. Okay. Division operator.
So maximum question comes from the SQL and basic SQL. Maybe on that note, if you can just give some few questions, and ER diagram and the joins when we're calculating the maximum and minimum number of rows.
Hmm. But
So
they
maybe
are quite practical, so it will be logical to go and solve questions on them.
maybe
Currently,
the three.
I was
The three
yes.
one like relation algebra, which has maximum number of questions, including the SQL and basic SQL. On those note, if you share few questions, that will also be good if we have time today. Maybe we can be solve some questions from other PYQs or.
Yeah, let me just do that. First of all, I'm just trying to explain some concepts. Then we will move on. I'm just picking the concepts according to my insight because uh,
Sure.
otherwise it will take a lot of time. So if you see an ER diagram, there are 2 things that you should clearly understand. First of all, this is an entity set, right? These are the attributes which are in the oval. They are attributes. And in the rectangle, you will see the entity set. In the diamond, you will see the relationship set. And if a relationship is like this double lined um diamond and there is a entity set with double lined rectangle, it means this is a which type of entity entity set? Weak entity set.
Weak.
We.
Weak entity set, right? And when you see the double lines attaching from an entity set to a relationship set, it means full participation. What do we mean by full participation? By full participation, we means that if in the health table I have 5 rows, okay, then these 5 rows should participate in this relationship at least once. Okay. If it is many to many relationship, maybe this health can participate in this relationship multiple times. But the guarantee is that all 5 rows must participate in this relationship at least once. This is the meaning of full participation. Okay. When you see this arrow, it means one cardinality. When you don't see arrow, it means many cardinality. So if you see instructor and courses, there is one to many relationship between them. Okay. So
Sir, can
between
you repeat
works,
the arrows, sir? Sorry, I missed that point.
whenever you see arrow, it means one cardinality. That means one instructor will participate, will make a relationship with multiple courses.
Okay. Okay.
So this manager relationship is saying that one instructor can manage multiple courses,
Okay. Okay.
right? But one course will have only one instructor. One course cannot have multiple instructors. This is the meaning of one-to-many relationship. Okay, so this is the basic information, and I'm not going to deep into that. We will just go to the questions when we want to discuss those type of things. Let's discuss TRC. So in TRC, the syntax is like this: you give a tuple such that there is a predicate. For example, if someone had given me the students table. In this, I have roll number and I have name, and then there is a separate table called courses. In courses, I have um, the course ID and the course name. Then there is an enrollment table. I'm just calling it ER. And in that, I have roll number and I have CID. Okay. So I'm just trying to find such courses, such students who are enrolled in some courses. Basic TRC, right? So what I will do, I will say there is a tuple such that there is an existence of a tuple S or anything, you can call it anything from students table. Then there is one more existence of C tuple from courses table. Then I will open the parenthesis and I will start giving the condition. The condition is S dot roll number is equal to ER dot roll number. So I'm just giving some condition. For and we use this symbol, and I will give the second condition, that is C dot CID is equal to ER dot CID. I think I forgot to create one tuple for ER. Let's call it E, belongs to ER. And here, let's use it directly. So you can see this is the basic flow of TRC. We are trying to create a tuple, and then if we want to return a specific set, a specific type of things. For example, I want to return a student name. So I will say T dot name is equal to S dot name. As simple as that. And in this tuple, there will be a collection of student names only.
Sir, can I ask something?
Yes.
Here in the first line you have written S element of student and C element of courses, no?
Hmm.
That is equivalent to the from statement in SQL query, no? Or
Yes.
and this first T represents the select.
Uh, you cannot just
Just
you can visualize
this,
them and
yeah,
relate them,
yeah.
but there is no such
No.
conversion happening at all.
I'm just relating both. That's why.
Yeah. You can relate it like this. It is
Okay.
selection.
And
Yep.
this is the end. Last one we can like where condition. Like it is similar to that.
This is a selection with
Yeah.
the regards of TRC,
Okay.
and you can give the where conditions also after that. If you want to select only those students, some specific students, some specific courses, you want to add condition, you can do that.
Okay.
Yeah. And in domain, you just give the domain as the output, and again, you go and define the domain. Either you can give the condition directly in the domain. If you give a variable like this, if you give a name like this, it means you are giving a variable. For example, in a student table or student entity set, I have two things: the student, the roll number, and the name. So I can have a domain like this: A comma B belongs to student. But let's say I want only those students whose name is Ram. So instead of making it a variable, I can directly give a string called Ram. So I will, this is a direct selection, direct filtering. We don't have to go and say B is equal to Ram. We don't have to give explicit conditions. So DRC, writing DRC, you can do in multiple ways. Okay. Either you can give the direct value here, or you can go and give the condition, whatever you prefer. Okay. So this was the basic discussion. We will see everything else in the when we will solve the questions. Referential integrity constraints, I assume you already know what happens if we have referential integrity between two different tables. If we have a student here, if we have courses here, let's say we have roll number, and here let's say we have CID and also roll number. Let's say it is one-to-many relationship. Okay, so this is a foreign key here. Okay, and if we have two students here, 1 and 2, and for student number 1 I have two courses, 1 and 2, for student 1 only. Okay, so if I delete this student from student table, then these two will also be deleted. This is the meaning of cascading. I am deleting only this, but because this one is matching the foreign key 1 and 1, our SQL will relate it. If we added the referential integrity cascading, then our SQL will automatically go and it will delete these two rows. Okay, as simple as that, nothing complex happening here. And it is just to uh, protect our database from stale data. If we don't delete these rows, maybe it can be stale. We don't have a student, but we are in like storing some information regarding that roll number which doesn't exist in reality. So it is incorrect information which can cause some inconsistencies in the database. That is why cascading exists. Okay. Now, basic SQL, it is a practical thing. We will just go and solve the question. Same for subquery. Division operator. Again, it is very simple. I discussed it again and again. If we have a table A, and in this table I have two attributes A and B, and it is, let's say, two attributes A and B, and this table name is, let's call it A1. Okay, and here I have A2, A3, again A1 and A2 and A3, and here I have B1 and B2, B2 and B3 and B1, and in A2 I have only B attribute, and I have only B1 and B2 here. Okay, so when we do division, if you want to find out A1 divided by A2, what we are doing, first of all, we are doing column based filtering. Whatever column is present in A2, if it is also present in A1, focus on my words, if it is present in A1, we will eliminate that in the division output. We are not removing it from the main table, but in the division output, there will not be any attribute called B. Other than B, whatever is there, it will be present in the output. Whatever is there in A1 will be present. So other than B, A is present. This is column based filtering. Now in row based filtering, we want only such A's where for which B1 and B2 both exist in the same row in our A1 table. So if you go and see the A1, we will start with A1. For A1, B1 exists. You can see in the same row, B1 is existing. And for the same A1, B2 exists. Right? So the condition is satisfied. So A1 will be included in the final output of A1 divided by A2. A1 will be included in this output. Then we will pick next unique value, which is A2. A2 is coming 2 times, but it is B2 and B3, not B1 and B2. So it will not be included. For A3, only B1 exists, but B2 doesn't exist. So it will also be filtered out. This is how division operator works. Okay. Other thing
That means finally we will
yes,
have A1 B1 and A2 B2, right?
in the final
A1
output, we will only have
Only
A1.
A1.
only
The
A1.
final, yes, because for A1 only, B1 and B2 both exist in the same row.
Acha,
Right?
acha, okay, got it. Yeah.
Yeah. So
Okay,
final
got it.
output will be this A. The column will be A, and the instance will be A1. That's it.
Okay. Okay.
Now, final thing that I want to discuss here, other than that, everything is practical, which we will solve by going there. joins, this outer join type of questions. So everyone amongst you, I'm expecting knows what is outer join, right? Outer join does a very simple job. If we have students here, one, two, let's call it SID instead of roll number and name. Let's say we have three students, one, two, three, Ram, Sonu, and Monu. And let's say we have a courses table. In this also I have three courses. There is a CID and there is a C name. 1, 2, and 3. And DBMS, PDSA, and MLF. Okay. So in this scenario, let's say in the courses table, I have SID also. And this first student is associated with two courses. Okay. Or let's leave it blank. For now, I'm leaving it blank. Because I want to make you understand what is the meaning of that min and max that we are trying to figure out. See this data. Forget the foreign key for now. Just see this data. It is very simple data, right? We have three students and three courses. Based on what I fill here, it will be decided that what are the number of rows in the outer join. Let me give you a very simple scenario. SID1 is associated with course ID1. That means Ram took DBMS, Sonu took PDSA, Monu took MLF. As simple as that. Can you tell me what is the number of rows in the output?
3. 3 again, because unique ID, student ID, yeah.
Yes. So what we did here, try to formulate the pattern. We spreaded this information of the SID. We spreaded it. I didn't say that it is one-to-one relationship, right? I never said that. But still, we tried to spread our SID in all the courses. We didn't try to give it to a single student. Now see a different scenario. All three students, out of them, only Ram took DBMS, PDS, and MLF. All others, Sonu, Monu, didn't take anything at all. Now tell me what will be the output of left join. Like how many rows?
The column will be remain same. Na? If the left join, so the columns present in the left table, it will be the one. Like let us say Ram, Sonu, and Monu will be there. If we do the join like left join, so
what happens in left join?
Like left table remains like is taken as it is, and whichever is matching with the right one we keep, and rest of the it follows as it is, because 1 2 3 will remain same. Ram, Sonu, and Monu. Coke's name I am not sure. Like
But this one is matching 3 times, right?
So 5, sir?
Yes, 5. So what is happening here? We are giving all the relationship to just a single student. So we are not spreading the students this time. We are being selective as we can, and we are being too biased to a single student for this relationship. And to after doing that, you can see we in the final output we will have three relationships. Of course, a join will made between them. First of all, Ram will make a join with DBMS, then with PDSA, then with MLF. And because it is left join, Sonu and Monu will come as it is. So there will be 5 rows, right?
No, then I was just missing that context. What about the final table look like? Will it only carry the student ID, which is 3 for Ram, another single entry for Sonu and Mono? What about the code's name? Will it not appear there? Or the final table, how does it look like? Like, can you please draw the final table in the left
In the
side?
first row, one Ram, one DBMS. In the second row, again 1 comma Ram comma 1 comma 2 comma PDSA. This is the second row. Third row will be 1 Ram 1 3 MLF. Right? It is very simple. For the fourth row, we will have 2 comma Sonu comma null comma null comma null. We will have null on the right hand side. This is how outer join works.
Okay.
Whatever is present in the left, take it and fill the null on the right hand side.
Okay.
Got it?
Yes, yes.
Yeah. So why I'm discussing this? I'm just discussing this to explain you how to find the min and max conditions. So in some questions, students are asked in if there is a outer join between students and courses, then what is the minimum number of rows possible and what is the maximum number of rows possible? Okay. So minimum number of rows, if you want to find out the minimum number of rows, then you should spread your data as much as you can. Right? If there is a situation like this, 4 comma Salim, let's say, in this scenario you cannot do anything because there are only 3 courses. So you can fill at most 3 values, right? So you
Why
are
not?
forced to make a row for Salim also. So what does that mean?
In Shaleen case, then that will be
Yes.
null, na? SID, CID, and CNAME will be null, right? We can
Yes.
still make that entry on the left side. That means the unique number of rows in the left side table, that will be the minimum,
Yes.
and the maximum will be the like when we're
Not on
spreading
the
that.
left hand side. Not on the left hand side. It is whatever is maximum between the left side or the right side. Whatever the maximum number of rows. For example, let me give you one more scenario. Let's forget the Salim condition. Let's add one more course. Uh, let's add one course called Med 1. And for that, the course ID is 4. Now I am forced to fill one of these values here because it is a foreign key. In foreign key, you cannot fill random value like 22. Right? It will throw an error. This is how SQL works. You need to fill a valid ID that exists in your database. So I am forced to fill 1, 2, or 3. And when I am forced to fill this, it will make a relationship. And the final rows, what will be the number of rows? 4. Right? And even if I fill 22 here, if it is right outer join, then it will consider this. It depends on what type of outer join we are talking about. So you need to be aware of what type of outer join we are working with and if we are following the foreign key constraints or not. If we are following the foreign key constraints, then we cannot fill random values here. And in the questions that comes in quiz 1, it is very common that you need to follow the foreign key conditions. So you cannot fill random values here. You need to choose either of them. Right? And when you choose either of them, it will make a relationship and the minimum number of rows will be maximum of number of rows of students or number of rows of courses. If courses are
No,
more,
minimum, how it will be maximum, sir? I did not understand. See, for example, in the SID 1 to 3 I have, so minimum will be 3 only, right? If I'm going for, let us say, matching with, let us say, one DBMS and one for MAD1. So that will be the maximum number of rows, right? If I do either left or right, but the number of rows maximum will include the all the possibilities. Like
Forget the maximum for now. Let's focus on the minimum.
so minimum will
In
be the
this
left.
scenario, if we are working with left join, what is the number of rows that you will get in this scenario?
In this scenario, maybe left one only 1, 2, 3 I have, so it will be minimum will be 3, right?
What about this?
No, you'll do the
Will it
join.
not make
After
a
the
join?
join, you will have 4.
And then maximum, if I have to see in the left join, if you're telling all the combination I need to take, that means one DBMS and one for MAD1 also I will consider for RAM, and
Yes.
Sono Mono 2. So that
No, it is
becomes
not the maximum case. This is not the maximum case. This is
the
not how
minimum.
we are finding out the minimum and maximum cases. In this scenario, this is the minimum scenario. You cannot go minimum than this one, because you can see we are using all student IDs in this scenario. So
Okay.
there is no possible scenario which can give us lesser rows than this. This is not the maximum scenario at all. This is the minimum scenario in which you will get the minimum number of rows in the left join. And in this scenario itself, you are getting 4 rows as the output. So that's why
Correct.
I said in the minimum scenario itself, you will get the number of rows as maximum of left and right. So in this case, right hand side had 4 rows. But I don't want to confuse you. Let's forget this formula. I'm just saying that don't try to formulate it with your insight. I found this formula, so I wrote it. If you want, you can use it. But the main thing is understanding what is happening inside. Why, in what scenario we are getting the minimum number of rows and in what scenario we are getting the maximum number of rows.
Okay, so that means the minimum row will be 4, and what will be the maximum in this left join?
In the maximum case, we will try to be as biased as possible. So what do I mean by being biased? I will give all the relationships to only one student. This is what I mean by being biased. Okay.
Okay.
Now see this. What is happening? This is making a join. This is also making a join. Again, this is also making a join, and this is also making a join. So 4 rows are coming from joins, and 2 rows are coming from that null case, from the left outer join case. So what is the number of rows? 4 plus 2? 6.
Okay, so even though, let us say you made it 1 1 1 1, but instead the earlier one, how it was 1 2 3 1. If
Yeah.
you make like that, in that case also, will it be 6 or 1 2 3? The
No.
SID
How it will be 6? Let's see that. If I do 1, 2, 3, and 2,
1 1. No,
then
no, no. Fourth one, no, no. We considered one. The last one would be 1, so that I do have the minimum number of rows is 4. Now
yes.
I am considering what is the maximum number of rows if I do the left join in this particular example. What will be the maximum here? Then it will be again the same, like 4, or will it be 4?
Why are you stuck on this scenario? In this scenario, maximum number of rows is 4.
And minimum also 4.
There is this particular scenario. In that scenario, there is no minimum and maximum. In that scenario, there will be only the final output. Right? When scenarios are changing, then the number of rows are changing. There is no min and max in the same scenario. In this scenario, you
So
can only
either
get 4 rows, right? Why there will be any minimum and maximum there?
either one, like either minimum approach or maximum approach in any particular scenario.
Yeah, we are handling the scenarios. Our target is to find the minimum possible and the maximum possible rows in the left join. So we are changing the scenarios. We are the one who are handling the scenarios. We are not finding out the minimum and
No, sir.
maximum in the
Actually,
same scenarios.
sir, one question was there. They had given 2 tables and they asked to do the left join, and they said, what is the difference between minimum and maximum
Yes,
number
that's
of
what
rows?
I'm trying to explain. In that question also, you will, in most of the cases, draw a schema like this, and then you will handle the scenarios. For example, let's go and see that question. 1 minute, let me find that question. Can someone tell me in which paper that question is asked?
So the paper I don't remember, but I remember the question.
Okay, I found it. I found it. So this is the question. They had given a relational schema. We have employee, we have department, and we have designation. If the relations employee, designation, and department have 100, 6, and 5 rows. So employee have 100 rows, designations are 6, and the rows are 5. What is the difference between the maximum and the minimum number of rows returned by the following query? And the query is doing what? It is creating a right outer join between employee and designation. So on the right hand side, we have designation. On the left hand side, we have employee. And we are trying to create right outer join based on the condition, right? Designation ID. So just forget this department for now. We are focusing only on this. Correct? So let me draw the scenario. Let me draw a very simple scenario. Okay. In the original question, they said that we have 100 employees. I am assuming instead of 100, we have 3 employees. Just to explain it to you. Okay. We have employee ID. I'm calling it EID for now. And let's say employee name. I'm just considering them because this is just a rough work. And I am assuming we have these 3 rows, 1, 2, and 3. Again, Ram, Monu, and Sonu. Okay, this is just the rough version of what is given. We are trying to understand what is happening. Second table is designation. In the designation table, okay, there is one more attribute that we should consider, and that attribute is designation ID. So I'm calling it DID. You can see designation ID is also given inside the employees, right? So this is a foreign key because this arrow is given whenever an arrow is given in these type of diagrams. It means this is a foreign key. Okay.
So the arrow direction, like the root of the arrow is the primary key, or the tip of the arrow is the primary key?
The arrow is pointing out to a key, and this is a primary key. And from where it is coming, this is the foreign key. So we have designation ID here and designation name. Okay. So let's assume in the original question, it is given that we have 6 designation. I'm still assuming that we have only 3 designations. Okay. So 1, 2, and 3, and designation can be A, B, and C. Let's not make it complicated. So you can see I'm again leaving this empty, just like I was doing here, right? Because just like this example, I will handle the scenarios. I will decide how to use the foreign keys to formulate the minimum number of rows and the maximum number of rows. So if I say that this designation ID 1 is related to Ram, this designation ID 2 is related to Monu, this designation ID 3 is related to Sonu. Okay. What will be the output? How many rows will I get?
3.
3.
3. Let's say I have 4 designations. Okay. I'm again changing my assumption. Let's say we have 4 designations and 4D. Now, can you tell me how many rows will be there? Same scenario.
4.
4.
Four, right?
Still, DID is a foreign key, right?
Yes.
So
It will make a relationship here, join. It will make a relationship here, join. It will make a relationship here, join. Because it is a right outer join, this will be matched with null on the left hand side. That's why 4.
no. Designation, how it can be
We are,
null there? It will force us to have a ID na, in the primary key, because
we are
in the
considering the max case, minimum case.
no
Okay, okay.
DID
You are
can be null
saying that
because it is a
no,
foreign key, as you
it is a
explained in the.
primary key here, right?
Acha. Okay, in this
So
table, if it is the primary, then it can be null there. Okay.
yeah, primary key can exist independently. There is
Yeah,
no
correct.
guarantee that full participation should be there. 4 should also be exist in the foreign key. There is no restriction like this.
Okay, correct.
But you
So,
cannot have the reverse. You cannot have 4 here without having
and
4 here,
yeah,
right? So you are right, but the conditions are reversed. So if I assume this condition, we have 4 employees and 3 designations. Let's say we have one more employee 4, Alim, and because just like you said, I cannot have 4 here because 4 is not here, right? So I can
correct.
choose either 1, 2, or 3. So I'm choosing 2. Can you tell me how many rows will be there in the output this time?
4.
4. So that is what I was saying, that in the minimum case itself, when we used all DIDs in the foreign keys, this is the minimum case. Okay. You are spreading as much as possible. All the IDs that you had, you spreaded them in the foreign keys. In that scenario itself, you are getting the
The
maximum
minimum.
number of rows between employee and designation. If we had 4 here, we got 4 as the output. If we got 4 here, then the output was 4. So
But
in simple words,
in the second condition, it will be because this is right outer join, no?
yes.
So there is nothing in the right, so it will
No, no,
not.
no. This time it is making a join, right? So we don't
Okay,
need that null type of thing. It will make a join with this designation.
okay.
Yeah.
So here in the
There was
route,
a
in
different
this
ID.
particular,
If there was a different DID here and not present in the designation, then it will exclude that value since it is a
No,
right
that will
outer
not be allowed. You can go in the playground, which we created. You can try it.
join.
If you want to add 4 in the foreign key, because it is not no primary key such that exists, it will throw error. You cannot have that scenario.
But this designation is coming from the employee, right? It is uh,
This DID is a foreign key,
employee.
right? It is directly being referenced from DID.
Okay.
But sir, the in the table of it is mentioned that it can't be not null. So that constant is not given in the table. So we can assume that the foreign ID can be null.
Foreign key can be null.
Yes, sir.
Yeah,
So,
if we have a null here.
that's what this was discussed on the like discourse, and we have the same issue there.
Yeah,
So
if we have null
because
here,
in the all
then it
other.
will not be matched with the primary key. And if it is right outer join, then this row will not be included.
Yes, sir, because in all other similar type of question, there was like exclusively
Hmm,
given that assume that it is a like not
correct.
null condition, but in this
Yeah,
question it was not given, so that created a confusion.
yeah. You can freely raise the discrepancy in that case because it is completely valid.
Okay, sir.
There can be two answers in this case, right? If there are nulls allowed, you can have 4 as the answer or you can have 3 as the answer. Both answers are correct because the question is ambiguous. Okay, enough talk with the concepts.
Sir, I have a similar
Yes,
kind of question is there in mock also. Here the same question but full outer join. Then
yes.
what is the maximum number of rows?
Full outer join.
Full outer join.
Uh,
Uh,
let's see the question itself. It will be
yes.
relevant to that, let me just
Question
go.
number 15, I guess.
Okay.
Now, question number 16.
Question number 16.
I am not getting the right answer, that's why.
So what is the right answer for this?
105.
I think it is the same schema, right? But the
Same,
null
same.
constraint is this time given. Okay. So employee department designation, we already saw. This is the same question. And this time they had given full outer join. So in the maximum case, what will you do? We have 100 employees and
And 6
we
basic.
have 6 designations,
Yes.
right?
Yes.
So this designation ID that you have
Yeah.
can come in the employees table how many times?
6. Maximum 6.
So is it the same? So we can use the same table.
Okay.
So not null constraints is given this time. So in the max scenario, I can have 6 different DIDs. So what I will do, I will just fill the single DID for all 100 employees, right?
Okay.
I will fill the same DID. How many times? How many employees are there?
100.
100 times. So how many rows I created by this?
100.
100?
Yes.
Yes. After that, how many designations are left?
5.
5.
5. So for them, because it is a full outer join, we have 5 rows. In total, we are having 105 rows.
Okay.
Was it the correct answer?
Yeah, one not. Yes.
So min will
Is there any minimum for this?
minimum.
Minimum is also easy, na? You can have uh, all 6 designations spreaded,
Okay.
right? And for all others, these designations can repeat however you want.
Okay.
So in
So
that
it's
minimum
100.
case, I think the
100.
rows will be
100.
100, right?
Okay. Okay. Okay.
So in this case, what you are doing, you are not leaving any designation without joining.
Okay. So here, if null is there, then it is 106.
If null is there, then the things are not like the answer is not simple, like not a
Okay.
single answer. You can have 105, you can have different answers.
Okay. Okay. Okay.
Sir, in summary, can you just help me out to understand the mean and max in left outer join, right?
See,
And
if
then
not null condition is given, then the
no, no,
minimum is very
not
easy.
no, not null. I'm not asking. In this particular scenario,
Yes.
maximum and minimum number of rows if left outer join, right outer join, and full outer join.
Yeah, I'm summarizing it in very simple words. If you are trying to find minimum number of rows, then minimum number of rows is just the maximum number of rows out of employee and designation. If the not null constraint is given, okay? If not null constraint is not given, then this is not going to apply. So in this scenario, we have 4 employees and 3 designations. So here we have 4, here we have 3. What is the maximum? 4. That is your minimum number of rows. That's it.
Okay. And what about the
If you want to
maximum?
find out the maximum, it is find the employee in this scenario. You saw that we filled 1 in all of them, right? And whatever the designation was left, that got repeated. Like we had 6 designation, one made relationship with all of them, all 5 got single-handedly. So we learned that if you want to find out max, it will be max of employee and design, just like the minimum, plus in the minimum scenario, in from the designation, how many rows did you get? 5. which is 6 minus 1, right? So min minus 1. So I'm making two mathematical things, but this is what I am understanding from this. So max, those out of them
Max.
is in employees, and in the min we have designation. So one designation is already used, remaining two will come from this formula. Okay.
Okay. This is the case in case of right out of join, right? Or the
Any,
left out.
it can be left, it can be right, can be full. I think I
So,
made a discourse post answering someone's doubt on these type of questions. I also gave the examples in all three type of joins. I think you should look into that.
sir, then in this case, it should not be zero, na? But actually that answer was zero, right? If you see that answer, which you were discussing in the beginning when I said that question. So that answer is zero. That means mean and marks, both numbers is coming to zero. Same number of rows and it becomes zero.
I think I need to see the question to answer that.
Okay.
So I'm pasting one discourse post list. In this post, I answered similar type of questions. So those who are interested can look into it. So I'm just picking this paper and we are just solving that because no time is left. Let's just see this quickly. This data is given and this query is given. Select region, comma, sum amount as total sales from sales where amount is greater than 3000 group by region, having sum of amount greater than 6000. So you can see we are using where and we are using having. We are making the groups after filtering out amounts greater than 3000. After making the group, we are filtering based on the sum of amount. What is the output?
West 11,000.
8,000
There are
and 1,000.
only West. We
No,
have three
east.
groups:
Yeah,
East,
since it says
East.
that
West, and
east,
North.
we will
North
eliminate
is
which
out.
are less than 3,000. So it will be left with the west only.
Okay,
Okay.
great. We are creating a table. Roll number is primary key, name and marks. Inserting a student with 1, 2, and 3. Updating a student where marks is less than 85, which means 80 and 70. Amit and Ravi. For Amit and Ravi, we are incrementing 10 marks. So Amit got 90, Ravi got 80.
Delete
Then we are deleting Neha.
equal to
We
Neha.
are inserting one student, Neha, with 95. So we got Amit 90, Ravi 80, Neha 95. Right? It is very simple. Auto part, auto suppliers, and catalog. They are asking you to match TRC and DRC. I'm leaving this question up to you. Or do you want me to discuss it?
So you can
Can you
just
do
help
that by
us.
yourself?
Yeah, no, sir. You just give us the trick how to quickly fetch the answer instead of.
There is no such trick. You just have to clear your fundamentals. So you just try to understand what this TRC is doing. In the first TRC, we are returning a tuple X such that there is a tuple from auto suppliers S, one from catalog, and one from auto part. And we are filtering Mumbai, price 5000, and then we are uh, filling the values in our tuple X. We want SID and P name. Okay, and then we are giving the condition for inner join, this inner join between auto part and auto suppliers using this relationship set. So in summary, we are returning SID. What is SID? Supplier ID. And P name. What is P name? Part name. So we are returning supplier ID and part name from location Mumbai and price 5,000. In this, we need to find out those DRC where two attributes are returning. If I see this, N is for S name, and this M is for SID, and Q is for auto suppliers. So Q is for here. P is from auto suppliers, which is SID, and P name is getting selected from N, and the conditions are also true. So I think G is matching with it, right? So you just have to filter out based on what type of attributes are being selected, and then what are the conditions given. So you can see in the G, only P and N are getting returned. P is from P is the first attribute of auto supplier SID, and N is the uh, N is from auto parts P name. And in our first query, these are the two things that we are collecting. So at least we are selecting the same thing. Then you will check the condition, and the conditions are also same. This is Mumbai and the price is 5,000. So I think it is matching with G. So after that, I filtered out that first two options are incorrect. Now I will just need to check the second one. Either it is A or D. So second one is doing what? It is selecting auto parts and catalog only. Then the name should be suspension, price should be 5,000, and the matching condition, right? The matching condition is this. We are selecting the PID. So what is the selection? PID. What are the conditions? The name of the part should be suspension, and the price of the catalog should be 5,000. Let's check the A. It is giving us M from auto parts, which is PID, which is what we want to give. The condition for suspension is correct, and 5,000 condition is also correct, is from catalog, right? And M is equal to A is the condition for inner join. So I think this one is correct, but to be sure, let's also check the D. It is returning M from auto parts. N should be suspension. Okay. And from the catalog, C is 5,000 and M is equal to A. So I think both of them are doing the correct thing, but the difference is about the syntax, right? Both of them have the same selection and same conditions. Which of them is using the correct syntax? This is the question. What do you think? Is A correct or D? What is the correct way to use DRC?
A.
A?
And M is equal to A is given the condition in A, while in C it is missing.
Actually, we are
So you're
saying D.
comparing it D, okay. Oh, there I
Yes.
It should have their exists there. The syntax is incorrect in that case.
Correct. If you see all DRC, there should be this existence quantifier, right? Which is missing in the Dth option. Okay, we selected G as incorrect. Our A was correct. For one, we had E and we selected G. Let's quickly distinguish between them. MNO, auto parts, EQR, auto suppliers, R is Mumbai, ABC, catalog. Okay. In G, we don't have the inner join conditions. In E, we have. Yep. So it requires you to closely look at all the conditions being satisfied or not, and also try to match the matching condition, the inner join conditions. Match all four options to be sure. We just try to just solve two of them. If we would have moved forward and also checked for third option and the fourth option, then this option would be evident as incorrect. But we just hastily checked two options and moved forward. Two things to understand here. First of all, we need to be sure with every single condition it should be applied. The partially correct output looks correct, but it is not. And the second thing, we should try to check all four
This
conditions.
question takes a lot of time to solve.
Yes, we are moving very quickly. So, employees, this is the query, and they are asking what this is doing. Select name from employee A1 where salary is greater than select max salary from employee A2 where A2 department is A1 department and A2 dot experience is less than A1 dot experience. These questions are also very common and I think they are very easy, right? Select max of salary. We have two employees. Their departments are same. The employee that we are selecting is more experienced and his salary is greater than the maximum salary of such employees who are from the same department and who have less experience than him. Which option is correct?
C, like who earn more and less experienced.
Correct.
C.
Less experience, yeah.
Names of employees who earn more than the all less experienced colleagues in their department. Student course and enrollment is given, and I think we already discussed this question. Student professor course and all teach which of the following relational algebra queries will list the names of all students who have taken every course taught by Professor Smith. This is the name of all students name who have taken every course. So taken means we need to join with enrolled using student ID. Then every course taught by Professor Smith. So this Professor ID, the name Professor Smith will be coming from this professor table. So we need to also join this. And this Professor ID will come from this teaches, right? So student, professor, enrolled, teaches. These are the four tables that we want to join. Now tell me which option is correct regarding that. There are some division
A,
operators.
like, because it requires Professor Smith, so we can filter out like A, C, D, Professor Universal Join with Teachers, because Professor ID is there in the teachers table and Professor ID is there in the professor. So Professor Join Teachers, the first one should be the case. because D does not, professor is not universal join with course. It will be professor ID and professor ID, both professor and teachers is there. So A should be the case.
A is the
Because
correct answer, yeah.
A is the correct one.
I'm not sure, but I think the professor and
A is
teachers,
the correct one because all other are not going to give the output that we want.
because if you see the last that name is Smith and professor and teachers is the union join, which is getting divided by the student ID and course. Yes.
What about the second one?
Second one, actually, it is professor, then teachers. Okay.
It
But
is only
enroll,
taking the
yeah,
student ID. That's why it is wrong. From a student, it is joining just the student ID, but we need student ID and course ID as well from enrolled. And it is taking from professor, but we want student ID, course ID from enrolled.
we need course now. So
Yeah.
second B does not contain course. Like that is the reason we should exclude immediately.
Yeah,
It is
it does not
asking
have course as well. It
the,
is incorrect,
yeah,
absolutely.
yeah. It is really
And
name of the
last
student
option,
who take every course now. So course is not there in the second B option B. So we should immediately exclude that. Course is
and
not
in the
there.
last
I
option,
think
this, everything is same as first, but it is joining it with the course instead of teachers because what we want is the teacher is the name having
Yeah.
the name Smith.
I think second is correct.
Professor, teachers, professor should.
Because the first one, it eliminates Professor Smith, no?
No, it doesn't. You joins with teachers. First one it join professor and
No,
teachers.
this division operator is there, right?
Uh, so we are getting the second query, which is course ID teachers by Smith, and it is the join with teachers. If you see the denominator in case of D, it also does professor and course, not teachers. If you see the teachers table, now it contains professor ID and professor contains professor ID. In that sense, we are joining both with professor ID and getting the query. So, and possible like we can exclude B, but ACD out of ACD, then we can think of A over D. Yes, sir. I think A the mostly, but you can tell us if it is correct.
So all agreed with option A.
I
Okay.
Yes.
What this decision division operator is doing?
Like we are getting total number of students divided by
Yes.
total number of courses by that particular teacher. That is a Smith. So we are getting the list of students by Smith. First query is getting the total number of students. Second query is giving the courses taught by Professor Smith. So division of that, we're getting list of students who are getting by Professor Smith.
Correct. This is just the course ID of all those courses that are taught by Professor Smith,
Hmm.
and this is the student ID comma course ID pair of enrolled status.
Yes. Yeah.
Makes sense.
so why the second option is wrong? Option B.
In the option B, we are joining teachers and enrolled first
Okay.
based on the course ID.
Course ID, yes.
Then after that, we are selecting those like professor with the name Smith only.
Okay.
Not after that, it is the collective natural join between all three of them, right?
If
So
this
between
bracket was not there, that would be right. In professor is in brackets, no?
No, no, it is just for selection, right?
Uh-huh.
We are doing all three of them together. So professor is being related to the teachers based on professor ID and
Sir,
enrolled. Yes.
sir, actually, B, what it does, no, like it also includes the teacher, which is like the students also, this is also listing the students who are taught by other teacher also. It is not filtering out only Smith professor. It like it lists all the list of students who is taught by Smith and also others, because it is joining with Smith. That means it will include every teachers. It is not filtering out only Smith, which is done by the division operator in the first and C and D. So division operator is required to filter out by Professor Smith what are the list of students. So say option B is not filtering out; it is joining all teachers, including Smith also.
Actually, option B is doing what is doing is, if professor is teaching three subjects, and if a student has only one subject enrolled with professor, that is also included in this query.
Yeah.
But we
So it
don't
is not
want that
filtering
student.
out. Yeah, correct.
We want a student which has all three courses taught by professor. So in this second query, it also include any single course if a student is taken by professor. So we have to exclude that.
Yeah, that is the main difference. Focus on this word every. This is
Mm,
what
Okay.
making the distinction and making the second option is incorrect.
Okay.
correct.
Okay. Now I got it.
Yep. So it is selecting such names which like taught by professor, but this is not giving you a guarantee that this student had not taken course other than Professor Smith. This is the problem with the second option and other options also.
Okay.
So create table, I'm leaving it up to you, right? Average also it is really easy. We already discussed aggregation type of question. Okay, this is again important. Book, author, and rights. Choose the correct relational algebra expression to find the author IDs of those authors who have written books of both the science fiction and fantasy genre.
So both, and that means intersection, na? It will be the like
Yeah, can
uh,
be.
in that sense, option A will be the one. But before that,
Option A seems promising,
yeah.
but what is the problem with the second option?
Books and rights, okay, but there are science fiction genre, books and rights.
Because it is saying
Mm.
genre equals science fiction and genre equals fantasy. And
That
means
is,
it wants genre to be both science fiction and fantasy at the same time. At the same time, genre cannot be science fiction and fantasy both, right?
no, no, no.
This
It
is
is
doing the union.
question is saying both we need, na? Science fiction and fantasy.
No, no, no. At the same time, you are checking everything row by row, right? So if I pick
Mhm.
Harry Potter, it can either be science fiction or it can be fantasy. It cannot be both, right? This condition is asking us to check the same genre to be both science fiction and both fantasy. This cannot be. And fourth option also, this is the problem. So I think the first one.
Yes, by
So, so the
intersection.
second option is violating the atomicity constant, right? Like
Yep.
a cell contains only single value of
Yes.
atom.
Yeah, correct.
Which of the following is the main role of the query parser in query processing? This was in week one. Query parser does the main job of converting SQL into relational algebra, right? This one.
B.
Yes.
ER diagram shown below, which of the following statement is are correct? The instructor can work in various courses and courses can have more than one instructor. Is it true?
Courses have only one instructor, no?
Yes,
Instructor can have multiple courses.
correct. We will not store the information about a health record once the instructor leaves the organization. Concept of weak entity set.
It is not weak, na? Because it is a solid line. It's not dotted lines, right? Health
Yes.
information is weak.
This
Health
is
is
weak
weak.
entity set, right?
Health is weak, yeah. But actually, is it instructor related to instructor? Is it weak? Yes, because the in entity relationship set is weak, so that will be weak. Is
It
that the
is
meaning?
What do
Because
you say?
Because
instructor,
of full participation, it will remove.
no, no. Information set na in between that rhombus is joining between instructor and health.
no
That
weak
is
entity set can exist with the supporting.
Oh, but there's full participation. If you have full participation, if you remove a record, it should not be there anymore.
Before anything else, it is a weak entity set, right? It cannot exist independently. Is second option correct?
True.
we
No.
will not show information. No, because instructor and information, the relationship is solid, right? It is not a double line or not a hidden line. So between instructor and information, it is many to many relationship, and also it is a strong. It is not weak. Instructor to information table.
Above all, it is a weak entity set. That's why it cannot exist alone.
I think it is very simple, right? We discussed weak entity set in details.
Yes.
Yeah.
Weak entity set cannot, like any entity in weak entity set cannot exist independently. So if the instructor is leaving, indirectly they are telling that it is not present in the instructor's table. So whatever is related to it should also not be present. That's it. Because independently it cannot exist, the health information. The instructor can manage more than one courses?
Correct.
Correct. What about the first option? Is it correct or not?
Various courses and courses can have more than one. No, the second part is not correct. Na? Courses can have more than one instructor. That is not correct. One course will have one
Read
instructor.
the second option completely, see the ER diagram once again, and then tell me.
Instructor can work in various courses, yes, but the courses can have more than one instructor working in them. For one course, there cannot be multiple instructors, no? Because there is a only end point of arrow says that one course will have one instructor, but instructor can have multiple courses. So
Can you see
second,
we have two relationships here, right? Manages and works. And we
okay,
are
okay,
talking about work here.
yeah, okay. So in that
Work is
second,
many to many relationship.
okay, done. Then it will be that will be also work, correct.
What about the last one?
Table 5 are required to represent. What is table
Total
5?
5 tables are required to represent the given ERD into a relational schema. And I think we discussed it already. No, no, not for this one. But it's still.
5
What
matlab
do you
like
think?
courses, instructor, health information 4, no sir. We have 4, right? Health, like instructor, courses, information and health. Which one is the fifth one?
Works.
No, works with the relationship, na? Entity relationship. It's not a table. Entity
Do
table
we
will
really
be.
need 5 tables?
5.
Total 5 tables.
5.
So what are those 5, sir? I think 4, na?
Works also.
Instructor, courses, and health are the strong entity sets. Information and works require a relational table, so that is also.
Achha, okay.
So you are saying that 5 rows are required,
5 tables are required.
five tables.
So if it is a big, okay, maybe we can check if it is 5 or
See the weak entity set again.
Weak, there are two weak. One weak entity is health, and information set is also one weak. So minimum 1, 2, 3, 4. In that case, we can consider instructor, courses, works, and managers. These are the strong entities and entity relationships. Two strong entities, two strong entity relationship. Four, minimum four. These are the weak, so maybe we can exclude those two.
See, we need 4 tables, not
Yeah,
5,
yeah.
to store the information.
Because strong entities and strong relationship can hold all the information. Like 4 tables we can
Yes.
manage.
We don't need to create one such table for this information. Instructors, health, works, courses.
Yeah. So option D will not be correct.
Two questions left. I think this we discussed in detail, right? Is asking the difference between minimum, maximum, and minimum. It is 5, right? 100.
Zero. 100, that number of rows, the difference between this maximum and the minimum. Maximum is 105 and then minimum is 5. Department.
Is it because of the not null condition?
No, they mentioned it somewhere else. Not.
Not null is not mentioned. So, yeah, I think this is the discrepancy type of case. Department, employee, and project. They deleted department and they are asking the cascading effect of it. We have department, HR, IT, finance. They deleted department ID 2, which is IT. How many total rows will be deleted across all 3 tables, assuming we have used on delete cascade, excluding the row originally deleted from the department table? So you can see department ID is here, right? And employee ID is here.
So there are two tables. No? So if you take the department 2, that means there are 1, 2, 3 instances: Bob, Carmel, and EV. So 3 rows will be deleted. No?
Yep.
Department
But
ID 2. No?
they
So
didn't mention if employee ID is also cascading.
no. They are telling where department ID is equal to 2. That means department ID is equal to 2. That we have 3 instances: Bob, Carol, and EV. So the department ID is 2, na? So 3 instances will be deleted.
You're right. I'm saying that when this employee is getting deleted, okay,
Hmm.
so you can see this employee ID is being used as a foreign key here. So we
Correct.
should also consider the cascading here, not
Yes,
only
correct.
here.
Correct,
Yeah.
correct.
So 3 rows deleted here.
Hmm.
Now 102, 103, and
And
105, right?
yes.
102 is here, 103 is here, 105 is here, 102 is here, 103 is here. So total 5 rows here, right?
Yeah.
So 2, 3 plus 5, which is 8. Yep. But I think the question is quite ambiguous. They should explicitly tell that this cascading is applied in employee ID also. Otherwise, student will get confused about it. Okay,
Correct. This
so
doesn't say in total. Like it's actually even in the first instance, I thought only from the department employee table,
yeah,
but it also removes from the project table as well. So
hmm,
in total, if they will ask, like then it will be clear. Like in total, how many? So they have
yes.
asked how many total was deleted from across all 3 tables. Yes, correct.
Okay, fair enough. I think some of you are well prepared for the exam. So we are ending the session here. Keep preparing as much as possible and do your best in your exam. I wish you all the best for that. and also praying for myself.
Wishing
So,
you good luck, sir.
sorry.
Wishing you luck.
Good luck, sir.
Yeah, thank you so much.
Thank you, sir.
Thank
Sir,
you.
sir,
Bye.
regarding the